Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In our previous video tutorial, we looked at classifying LandSat 9 images for my region of interest, and we also classified a LandSat image for my region of interest, and in both cases we used a median 2023 image. So that would be a medium image for the whole year of 2023, and we generated the classification images and we compared the overall accuracy between using the LandSat 9 dataset compared to the Sentinel dataset. And the results suggest that using the Sentinel actually gives better classification results as the LandSat, which is not too surprising given that the Sentinel operates on a much lower resolution than the LandSat data series. Okay, so but in both cases, whether it is LandSat or Sentinel, it's evident that there's specifically when it relates to bare soil and urban areas where there's a lot of overlap, meaning the spectral signatures within those particular images between bare soils and land and urban structures are very, very similar. So therefore, the classification algorithm have a difficulty distinguishing between what is bare soil and what is urban. And we've also seen that there's some overlap between the mountain areas and the rivers and things like so. But that could purely be based because our ROIs or our training samples are not effectively placed or effectively utilized. However, a possible solution could be to minimize those images where there's a lot of bare soil. And we know that this particular region of interest is a winter rainfall season. And we know that in this region of interest during the summer periods, there's a huge amount of land laying fallow and representing bare soil. So to minimize bare soil, it's possible to, for example, use only images that is representative of the winter months, which theoretically should minimizes bare soil, the prevalence of bare soil in our region of interest. So this video tutorial will therefore focus on that particular theory to see whether it holds any merits or not. Okay, so we go to our Earth Engine, and I've opened two of my projects. It's exactly the same project. Okay, so I've got, let's call it the one on the left and the one on the right. The script, everything's exactly the same. The only difference between the two is that in my left script, I have filtered the date or the images to only display summer images. Okay, to only display summer images. So that's typically from November, December, January, February, and March. That's when the area is at its driest, meaning bare soil is at its most prevalent. So one would assume that there will be much more confusion in the algorithm between bare soil and urban areas, etc., etc. The second image, I call it the right-hand image, is where we looked at winter month images, okay, which is typically May, June, July, August, September, thereabout. Okay, so remember that this region of interest is winter rainfall, and obviously southern hemisphere winter is on the middle of the year, June, July, compared to summer, which is December and January. So the rainy season for this particular region of interest is in the middle months or the winter months, around June, July, August. That's when it's on its greenest and it's on its driest over December, January, and February. Okay, so on your left hand side we have the summer images, and on your right hand side we have the winter images. Okay, and again, in each of the cases, on the left hand side is LandSat, and on the right hand side is Sentinel. Okay, so on this left hand side it's LandSat, on the right hand side it's Sentinel. Okay, so before we actually look at the images themselves and compare the images with one another between let's call it summer months and winter months, i.e. lots of bare soil compared to fewer bare soil, much more green area versus much more gray area. Let's look at the overall accuracy statistics. Okay, so let's bring it down so that we can compare them in one set. Okay, remember, let's look at it one by one. So the first overall accuracy, remember, is the LandSat, and it's a standard classifier. Okay, so remember, our first classifier is the card classifier, and then the second is the random forest. So this is LandSat. Remember, there's them. So it's LandSat card classifier 78% for summer months. Remember, this is summer. Let's go down. Summer months. Okay, let's just go back there. And then this is winter months. And let's go there. And it's 0.7. 78%, 0.7. Looks like summer month, it's more accurate than winter months. Okay, let's look at the next one, which is the Sentinel using the card. Okay, that one there. It's a Sentinel image using the standard classifier. Gives you 98 for summer and 100% for winter. Interesting. Okay, so again, Sentinel is better in the winter. LandSat is better in the summer. Very interesting. Okay, let's have a look at the random forest. First of all, it is LandSat. Okay, 0.79. And look at LandSat winter, 0.74. Okay, so suggesting that for LandSat, summer is better accuracy than winter. Let's look at the Sentinel random forest, 0.94 for summer and 0.92 for winter. So 3 of the 4 classifications suggest that summer is better for accuracy than winter, which is actually counterintuitive with my theory. But anyway, it could be for a host of reasons, not just because of the bare soil issue. Okay, but it does suggest that using summer images is better classification than winter images. Remember, I'm not looking at the issue of the ROIs, the placement of the ROIs for your training samples. I'm only looking now at the difference between 2 distinct periods in a year, i.e. the high winters and the high summer periods. Okay, so let's have a look at my classification. Okay, so pull it. Remember, the left is LandSat and the right is Sentinel. And you can see the difference again between LandSat and Sentinel. Sentinel on the right hand side, much more. Remember, the pink is the soil and the red is the urban. And you can see that on the Sentinel on your right hand side, much more bare soil than in the LandSat. Doesn't reflect that lot of bands. So that's the summer. Let's look at the winter. Now this is interesting. In the winter, there's lots of bare soil in the LandSat, which is counterproductive, whereas in the Sentinel it's less. Let's have a look at Sentinel. Remember, that's a Sentinel image, this one. The Sentinel image for summer versus the Sentinel image for winter. You can see the difference, that the bare soil here, it's in the winter, it's much less than the bare soil in the summer. You can have a look here. Look at this area here. For example, you can see in the winter much more blue, rain. Look there, much less rain. Okay, so you can see that there's a different, let's have a look at this particular area here on top, which is also quite a bit of bare soil in this particular area. You can see there lots of bare soil in the summer. You can see in the winter much less bare soil, more rain, more blue. You can see there big difference. So, but if you look now at this, the LandSat, you can see again the LandSat much more green than in the much more green in the winter, this one here, than in the summer. But if you look now, for example, down here, that's interesting is that this is the winter. In LandSat, the winter images actually indicates more bare soil than in the summer. Look at this. This is a summer image for LandSat, and you can see much less bare soil than in the winter, which is counterintuitive again. Anyway, so the results seems to be, from a statistic point of view, fairly unambiguous in that LandSat is giving us, after the summer, is giving us better overall statistics than the winter, which I found strange in my case, but anyway, that's what visually the results are quite different depending from location to location within the region of interest. In some cases, as I said here, you can see this is winter. Let's confirm for you that this is winter. You can see there 23 of the 5th month to the 10th month. Have a look there. Also LandSat 9. Remember we were working LandSat 9. It's 23/5. So this is winter. And you can see there's quite a bit of bare soil. Whereas in the summer, which is when bare soil is on its most, you can see there's much less bare soil than in the winter. Which is fascinating by itself. Yeah. So the results are, you can see here, okay, LandSat, yeah, you can see the amount of blue on the LandSat in the summer. This is winter versus the summer. So the results seems to be quite surprising. It seems to be quite counterintuitive, and one most probably will have to drill a bit deeper. But again, it could simply be because of the positioning of our ROI. So we've looked at for the whole year, and for the year as a whole, Sentinel and Random Forest seems to be the better classification method. When we compare to winter and summer, the results suggest that LandSat and again Random Forest is the better option. Okay, so in both cases, it's interesting results. What I would suggest is that to improve it, it's not just simply looking at between different periods within a year, but to actually coming back to our argument that we have to adjust our ROIs or training samples. That seems to be the preferred method of improving our classification method. Interesting results, and yeah, something to think about, specifically when you do the classification. Okay, well, thank you for watching this video. Thanks for being part of this fabulous and mind-boggling journey of remote sensing. Stay tuned for the next step in our journey, or the next adventure in our journey, and I'll see you on the other side.